Welcome back, class. Today we're going to be focusing on a new method to solve systems of equations, and this method is called substitution. So far we've focused on graphing systems of equations, and that's worked great. We've looked for where those graphs cross, and that's where our solution to the system is. Today we're going to be working on a new method called substitution, and that's where we solve the system by substituting equations within each other. Now, just like when we graph systems, that worked great when we had two equations that were both in y-intercept form or slope-intercept form. Substitution works really good when you have one equation in slope-intercept form and the other equations in standard form. So when you see equations that are, when you see systems that are set up like that, then substitution is a great method that you can use to find the answer to that system. There are 3 steps for solving a system using substitution, and step number 1 is to solve one equation for x or y. It doesn't matter which one you choose. Most of the time they're going to be set up already solved for y because they're in slope-intercept form. But solve one of the equations for x or y. Step number 2 is to substitute that expression into the other equation and solve for the variable. And I'll show you what that means. We'll do a couple examples here and I'll show you what to do for that. Finally, step number 3 is to take whatever value you got for your answer for that variable and substitute it back into that first equation and solve for the other variable. That way you get 2 answers. You figure out what both your x and your y are equal to. So those are the 3 steps that we're going to use. Let's do a few examples to practice and see how it goes. All right, in example number 1 here, we've got a system of equations. We've got 2 equations with 2 variables. There's a y variable and an x variable. And we're going to use these 2 equations to solve and find out the value of the variables. Okay, so step number 1 is to solve one of the equations for x or y. Well, if you look at this first equation, it's already solved for y. It's y equals 6x. So step number 1 is done. Step number 2 is to take this expression and plug it into the other equation. This is what we've got. We know that y is equal to 6x. So here where we have a y, we're just going to put 6x instead of that y. This is what it'll look like. Let me rewrite this second equation, but instead of y, I'm going to put that 6x. All right, so that's what the equation looks like when I replaced the y with the 6x. I substituted 6x in for the y. Okay, now we can use our order of operations and solve this thing out. I need to distribute this 3. 3 times 6x is 18x. So I've got 2x plus 18x equals negative 20. Now I can combine like terms. I've got a 2x and an 18x, so I can combine those together. And 2x plus 18x is 20. I've got 20x equals negative 20. So now I can divide by 20. And when I divide by 20, I find out that x is equal to negative 1. So that's half the answer. I'm almost done. I know that x is equal to negative 1. That's one variable. I need to find out what the other variable is. So that's where we get to step number 3. And step number 3 is I take this value that I figured out for x, and I plug it back into the first equation. So I know that y is equal to 6 times x, but x is equal to negative 1. So I substitute that negative 1 in, and I get y equals 6 times negative 1. So then, of course, y equals negative 6. Now I know that x is negative 1, and I know that y is negative 6. And just like when I graph these systems, I put the answer in an ordered pair. So same thing here. I'm going to put the answer in an ordered pair. The x is negative 1, and the y is negative 6. So there's the solution to this system, negative 1, comma, negative 6. All right, let's try one that's a little more difficult. All right, in example number 2 here, again, I have a system of equations. I've got two equations with two variables, and I need to solve this system and find out the value of each variable. Where these lines meet, if I were to graph them, where would they cross? Okay, where are these two equations equal? So my first equation is y equals x minus 3. Step number 1 is already done. My first step is to solve one of the equations for x or y. So this one is already solved for y equals. So now I move on to step number 2. I take whatever y equals and I plug it in wherever there's a y. So in this case, I'm going to replace this y with x minus 3. So I just rewrite that second equation, except instead of y, I put x minus 3. And now again, I have to use my order of operations and see if I can simplify this expression here, this equation. So I'm going to distribute my 2. Once I've distributed my 2, I can combine like terms. And now it's just a two-step equation. I can add 6 to both sides. And I get 8x is equal to negative 8. When I divide both sides by 8, I get x is equal to negative 1. And don't stop there. That's only one of the variables. We need to also find out what y equals. So this is where we move on to step number 3. I'm going to take this value from this equation, and I'm going to plug it back into the first equation to figure out what my y was. So I'm just rewriting that first equation, y equals x minus 3, except instead of x, I'm going to put negative 1. Y equals negative 1 minus 3. And negative 1 minus 3 is negative 4. So I know my x is negative 1 and I know my y is negative 4. So the solution then in an ordered pair is negative 1, comma, negative 4. And that's the point where these two lines will cross. That's the solution to this system. Let's try another example. All right, so in the first two examples, it was always the first equation that was solved for y. But in this second example, when we look at the two equations, the top one is not solved for a variable. The bottom one is the one that's solved for a variable. It's the one that has y equals x minus 8. So we're going to take this x minus 8, and wherever there's a y, we're going to plug in x minus 8. So I'm going to rewrite this top equation now. There we go. All I did was just substitute x minus 8 in for the y. Now I need to do some order of operations. I need to distribute this 4. So I distribute the 4 into my parentheses into that x minus 8. Now I can combine like terms. And again, now I just have a two-step equation that I can solve. I just have to add 32 to both sides. And I wind up with 6x equals 18. And finally, I just divide both sides by 6. I get x equals 3. I'm halfway there. I know one of the values of the variables. Now I just need to plug in that 3 to find out what y equals. So I'm going to choose this equation where it says y equals, and I'm going to plug in this 3 wherever I see an x. All right, so I just rewrote that equation, except instead of x, I put a 3. Then I solve it. I get y equals negative 5. I know my x is 3 and I know my y is negative 5, so as an ordered pair, it's 3 comma negative 5. All right, I've got one last example that's a little bit trickier. Let's try this last example. All right, one last example. Again, we're solving systems by using substitution. We're not graphing them any longer. We're using a new method to solve this systems of equations. Step number 1 in solving systems through substitution is to solve one of the equations for either x or y. This first equation is already solved for y. So step number 1 is already done for us. Step number 2 then is to plug this expression into the other equation. So I'm going to take this 2x plus 2 and I'm going to put it wherever there's a y. So I just rewrote that second equation, except instead of y, I put 2x plus 2. Because I know that that's what y is equal to, 2x plus 2. Now this one's a little bit trickier because when I distribute this negative 6, I need to remember to distribute that negative along with it. So don't lose those negatives. I know that's usually the spot where we make our mistakes. So be very, very careful with your negatives. Pay close attention. The details definitely matter. So I've got 5x minus negative 6 times 2 is negative 12x. And then negative 6 times 2 is minus 12 equals 2. Again, now I can combine like terms. So I look for the x's. I've got a 5x and a negative 12x. I combine those. That's negative 7x. Now I've got a two-step equation. I can add 12 to both sides. When I add 12 to both sides, I get negative 7x equals 14. All I need to do now is divide by negative 7. I ran out of room there a little bit, but I end up with x equals negative 2. I know my x value now. Now I need to plug that in. I'm on to step number 3 now. I need to take that x value, plug it into the first equation, the one that I started with, and find out what y equals. All right, so I just rewrite that first equation. Wherever there's an x, I plug in negative 2, and now I just solve it algebraically. End up with y equals negative 4 plus 2, or y equals negative 2. So I know my x is negative 2, I know my y is negative 2. Now I just write it as an ordered pair. And that is how we solve systems of equations using the substitution method. I've got a few more practice problems in the notes for you to try. Hopefully those come easy to you. If not, you can go back and look at the steps again in this video or look at some of the examples that we did to work your way through those examples. I hope it comes easy to you, and I'll see you next time.